Buenos días. Vamos a comenzar con la segunda sesión de esta jornada del día de hoy.
We're going to start with this second session today. We're going to deal with the use of drones for risk management. My name is María Teresa Queralt. You can call me Maite. I'm in the regional engineer team. It's well known as XXV. And I am very happy to be here in this session. We think it's going to be very interesting because the use of drones is widespread, and we believe the future of drones is going to be very interesting. The director of the drone and head of safety in flights. He's an instructor of civil pilots, and he's a pilot himself since he was 30, 9,000 hours of flight. He's also an inspector of flights in the Department of Aerial Safety of Europa. And he studied in the ES Business School, and he's an expert in image processing for industrial and electric infrastructures using thermal images. You can take the floor.
Bueno, pues buenos días a todos.
Morning to you all. First, I'd like to thank María Teresa and Mapfre in general and César for having given us the opportunity to be here with you today so that we can share with you our experience. Bartolomé and Carlos are the other speakers of this session, and we got together and we thought we wanted to do something that would be fun, a bit basic also, and quite open. Because, okay, I have a good CV and everything, but Bartolomé is the true expert here. And Carlos, that's the same, well, he's also a very experienced person. We both work in the industry of energy. And, well, my presentation is going to be quite open. And, first of all, I'd like to say that I have added some sentences to my presentation to deal with the philosophy and technology. Also, knowledge, science, reason, and understanding. So we're going to start with this sentence by Jean-Paul Sartre. Going to go from the modern things to the older things, and we're going to deal with technology from the beginning to the most modern things. So an inverse work. So, the beginning of drones was in the military sector. Can you have an image, visual image, before we go back to this sentence? The sentence is, believing is summarized in confusing things with their name. Okay, I want you to know that I'm adding these sentences because I have an abstract reasoning, and it would be leading to the final sentence of Socrates. There was a school in America saying what you see is what, or what exists is what you see, and you will understand it all at the end. So here we have the images, the wings, the aircrafts, the drones. Good morning, passengers. I'm your captain speaking. So, for drones there are With drones, there are people in favor and people against. This is an advantage for us because the technology is growing in terms of development, but also in anti-development. And that's a bit the concept of what I have on this slide. So everybody talks about drones. What are drones? What's this? Where does this come from? Drone, this is the etymology of the word, but in English it means the male bee. So sometimes people tell me I have RPAS company, RVANT company, a UAV company, or a drone company. But we need to understand those words. The idea here is that at the end of this session you should know what we really are talking about. So, where, when, why, and what for. So, where do drones come from? This comes from, playing, from radio control, and that's the origin of this technology. So, in the end, everything, well, we have the beginning of this development, and from game to work. Can you see those sentences? It's there. They are there, these sentences. And this presentation is going to be very quick, so I want you to have these sentences to remind you the key ideas. So, from the radio control plane to a high technology drone with sensors, automatic systems, very advanced technology. Evolution. So, the mobile phone was the key element. The level in the mobile phone, it's really fun because you have, when you want to hang a picture at home, you can do this with the mobile phone now, with the level there, and also the compass. That's really the key technological element that allowed us to have an autopilot that was completely automatic. So, who dared invent drones? Well, the bright mind. Nikola Tesla was the person who built the first drones. We have drones, aerial aircrafts, but there are other drones. There are aerial ones and terrestrial ones and submarines too. So the first drone was designed by Tesla. This is the only image I found, and it was a marine vehicle, and he wanted to invent it to avoid wars, but the first application of drones was a military application. So where and when? 2002, Afghanistan. So Predator was the first drone manufactured by Abraham E. Karen. He's the drone father. That's the idea. And then the CIA. I gotcha. So that's him and the first prototype of Predator. So what are the requirements for takeoff? Well, training, permits, insurance policies, prohibited areas, strict control of the documents by the public administration. So the need of regulation is there as a key door to the hell and to heaven. This affects the development, technological development, and also growth in this sector. In Spain we're well positioned, and this will lead us either to break or to develop, and sometimes breaks will help us become bigger, and also the swarm. And why? Because some years ago a drone was something that was really incredible, But now you can buy extremely great machines for just like 600 euros, and they are also potentially dangerous. Well, here training is really important. What for? If the use is just leisure, you have some margins, but if you're going to have a professional use of the drone, then you need to fulfill several requirements. That was the case of our company. When we looked at all the legal requirements, we understood that the best idea was to become really professional and be able to sell this also outside. And why? Because in some situations, in certain circumstances, these devices, these machines can be key in the development of history, for research, for search and rescue, the capability of working in an autonomous way. With a remote, we can have remote access, and with the current technologies and autopilot, we can do the monitoring of a network, respecting the law always, but it's incredible, the development. Also sensors, they are becoming smaller and the technology is improving. And this means that in this sector, well, it's really incredible the speed at which the technology is developing in terms of sensors. And also microphones are also important for search and rescue. So there's the drone, the sensors, cameras. All you need is drone. They can be used for 1,000 different purposes. In order to see possible things to emerging, you need to try once and again impossible things. Herman Hesse. So, let's do benchmarking. Helicopters. For me, that's industrial use in the electricity industry. That's the most important thing for me. And if we compare, in many cases, we cannot compete in terms of autonomy and also weight, because we are limited because of the weight of batteries. But we can compete in price, in how the images are obtained. So, because the helicopter can take pictures from one specific area, but we can get closer and take pictures from a closer position. So in this sense, less is more, and the technology is to our advantage now. This is the most recent mini drone, JI. Look at the size of the hand, and the capacities are really incredible in terms of image, but also technologically speaking. I don't know if you've seen the ad, but you can actually just move your hand and you can control the drone. The only limitation is battery because of the size too, but the technology is incredible. Experimentation and future. So what can we think about every time we look at the social media, we see the news? We really are always surprised. We see people skiing with the drone, someone jumping jumping off with the drone, also rescue situations. And we're like, wow, they're crazy. But the only limit is our own imagination. I've been told that in 2021 there will be taxi drones in Dubai. I don't know if I dare use one, but that's there. Talking to Bartolomé the other day, we were saying that this is a conceptual issue, and it's true. There's also 737 that is operated by a robotized arm, and there's the operation of real flight, and this robotized arm can land our 737, and the operation is just perfect. And if you're sitting there and you don't know that, it's fine. But if you know that it is a robotized arm that is controlling the plane, then I wouldn't, you know. When I was 30, first time I went to Santiago, and everybody was just feeling really sick. The flight was really hard, and it was not my fault. There was a lady at the end saying, and she said, well, you know, if I'd known the captain was so young, I wouldn't have gone onto the plane. So imagine what she would think if she knew it was a robotized arm controlling the plane. So we have, for example, uses for the emergency, sending, of course, medicines to remote, isolated areas, and there, of course, we all think it's a great thing. And, of course, here we can do whatever we want, and there are many interesting projects in this sense. Those who were, those who couldn't hear the music considered that those who were dancing were crazy. We always, you know, refer to mobile phones, but, you know, just a few years ago, we wouldn't have believed we would have so much technology in just in our hands. The fact of having a smartphone that has a greater IT power than the Apollo 13 computer. That's crazy when you think about it. So, are we sure? Before and after. So Mapfre, the use of these technologies is very useful for control, calculation of risks, risk of companies and critical infrastructures, flooding, or areas that can be flooded. We can quantify, audit, and that's before we can do a lot of prevention. Traceability is key. And we can do a checking indoor and outdoor. So we can do all sorts of searches to avoid serious consequences. Italy, a terrible tragedy. So everything was monitored with drones. And also, if in the left, if that's your building, Mapfre will know that, you know, they did a great thing because it's the only one that didn't fall down. So also the access to remote isolated areas, survivals, thermography, 30 Hertz, inspection capacity, also police. They already have drones, and they're using that to measure events. And also, if you have a problem and you need to go and check, it's not the same thing than if you simply connect yourself to the internet and you can verify what's happening. This is a picture. It's not only the jungle, but the fact that these areas are difficult to access, and that you have the capacities. Now, okay, the use, real use. Nowadays, there are already platforms in the US, platforms of insurance companies who have several autonomous operators, and For example, there was this thing, they have their flight plan, the drone goes and verifies the roof and then comes down, connects the drone to the internet, and from Texas to Washington they can have the information online and just do, okay, that's it, done. So we can do all this online and on time. A lot cheaper, no teams have to go there, and they can talk to the operator, the drone operator, and they can even move the camera and see what they want to see. So the conclusions, of course, the applicability of drones is there. This is something that we unstoppable. There is a great scientific and technological advance and development, and this is already there. Miniaturization of the equipment and technical evolution of the performance of the equipment, and for me this is R&D, but now it's simply IA. The future is not being a drone pilot, because in just a few years' time it will be an IT person who will be the pilot. And that's it, and this is my last slide. I cannot teach anything to anyone, I just can make them think. Thank you very much. I'm sorry I took a bit too long. Thank you very much. So, Miguel Ángel, thank you, and now we will give the floor to the next speaker.
Here is Mr. Carlos Bernabeu. He's the head of Arboria Interview, and he's the head of marketing and fabrication of arachnocopters and their application for the inspection of windmills. He's accomplished tasks, maintenance tasks for Iberdrola and Enel. He's the head of research for aerial maintenance carried out by drones. He's also a co-operator of the UAS School of the Air Army of the Spanish Army. And he's also responsible for the operations of his company both in Spain and abroad. Thank you very much, Maite. It's truly a pleasure to be here with you, with the Red family of Global Risks. And it is true that these days have become very interesting. Also, I'm very happy to see a full room. This is a subject which creates passions. I've been for many years working in fauna management, and there's an interesting concept which is fully applicable to these presentations, such as evolutionary convergence. You will see that Miguel Ángel and I share some slides, because of course we've applied an approach trying to transmit what the world of drones is in a general manner. And you will see also Tesla, a picture of Tesla and a picture of the drones. We'll speak anyway about different things.
Estamos en un momento muy interesante. Yo creo que los drones los tenemos que llamar así.
We're witnessing a very interesting time. Drones are referred to with such a name, even if I do not like it, but there's no way back. They are an element from a technological era. Are things running? Yeah, fine.
Un elemento que reúne
which gathers together a specific media interest. Sometimes I look for the drone term in Google. The conference I delivered in Pfizer, I found 144 million. It's gone up in terms of the searches, the number of references you can find in Google. This is an interest point, and it's clear. And at the initial presentation for this event, the drone was one of the keywords Mapfre had in mind. And why is such an interesting technology? It's just an additional tool, and it just reflects an evolution, as Miguel Ángel said, which is very much based microcontrollers and microprocessors, which right now are very powerful, very small, and what's most importantly cheap. And that is what has allowed for these systems, which are very old, which are not new, which were extremely expensive, were focused on a military aim, and we've been pioneering for some time in Spain. We started in 2008 thinking of an easy platform applied to civil engineering, and I will tell you something about the drones. When queen bees go up in order to set up new hives, the drones seek them in vertical, and they are the one who flies the highest is the one fertilizing her. So this is what in remotely piloted systems starts from. They started as many things in our life. It came out of the genius of Tesla, and from then on, a moment came when these microprocessors, microcontrollers, all got in hand, became cheap and powerful. So we have the ability to process real-time information from sensors, and these advanced concept of association high costs to remotely piloted operations. Also, the idea of having to use very heavy aerial systems for controlling maintenance. So suddenly the air is full of small objects, very autonomous, but they occupy the airspace, even if they are toys and they are handled by a child. The airspace has been regulated for a long time, so we're entering into a new field, and there's a challenge today. I wanted to speak about, after this introduction, I wanted to focus this on real experiences, because we may speak about what these will be regarding the future, or technology, or robotics. It is the future, but I can speak to you on what we're doing. We're forerunners in the structural analysis of windmill blades, and we did a deep audit of more than 1,000 windmills in terms of structural analysis. This is our technology. We have specifically designed Arboria. Arboria is a company with a platform of our own designed for this kind of operations. We started doing blade inspection in 2011. We were the first of the world applying this technology for this analysis, and our approach was developed thinking of predictive maintenance, that is, being able to detect problems in such big structures, such complex structures located at in heights. Access is difficult and costly, requiring ropes and monitoring techniques, and this allows us to do a structural analysis which goes beyond what is done by any other method. We're gaining the ability to see how through artificial sight systems we can measure the levels of defect of the blades and quantify them through an engineering study of those structures. Arbol is an engineering company, and this makes this product quite interesting for insurance companies, because it allows to understand the real risks posed by a structure, something which could not be quantified before. So we can now assess if a blade, which can be as big as 75 meters, will reach its useful life, and if not, which would be the shelf life, the limit we have to intervene, and manage for the blade to reach its useful life. With information gathered, we can know now the kind of action. If done on time, it will reach minimum costs and will extend the life of those blades. So large companies are very much interested in the extension of these structures, so they reach the highest profitability. So counting on precise information on the situation of a structure in internal and external terms, and if this structure will be ready to reach the end of its shelf life and being covered by an insurance policy without hidden risks, these allow us a predictive analysis. So drone is a mere tool, as a set of pliers could be. But the most interesting thing with regards to this new digital technological era is the ability to analyze an incredible amount of data, made it easier by these technologies, dealing with the world of big data with a big scale processing system which it allows us to detect things of the size of the wing of a fly, map 75-meter big structures, quantify the effects, arrange them, and generate automatic reports which make it possible for our clients not to lose any information. So the management of these assets, there are thousands of them all over the world. In the case of our clients, such as Vestas, Iberdrola, they are large utility companies. It makes them easy to centralize the decision-making process and apply large-scale decisions to correct this problem. So we are generating a predictive maintenance tool which sharply reduces risks. I've shown images of a blade which is in the ground and broken to pieces. So the costs are incredible, apart from possible risks, so we can be ahead of that situation. So traditional inspection systems do not let us to quantify and measure these problems we're having, and with these management ability of large data and digital formats centralized around the biggest expert in every company in our tablets, they have all the information of the blades at hand, and you may see how this is processed through artificial sight and damages are quantified. So you may intervene and you've got to stop the machine, and sometimes we have reached such fine-tuning that there are less than 74 hours till that blade is repaired. In other cases, an intervention is planned. In the analysis of the last season on a great volume, great number of blades, we detected a very outstanding percentage of blades which are not going to reach the limit of their useful life. They do not show any external signs. So our engineering analysis done by our experts who have been trained by Iberdrola for them to carry out these tasks. There's a lot of Iberdrola's experience in it. We've done a close job to develop a tool which is also becoming very useful for other companies, has rendered significant data. There's a large percentage of these structures which need maintenance and upkeep, and if we wait for these elements to show external signs, the cost will be enormous. If the blade starts breaking up, you've got to put it down, and the operational costs go down. If we wait until the blade is drops to the ground, if we're talking about old blades, some of the older models have no replacement, and they are no longer being manufactured such blades. So we're talking about those set of sensors, aerial systems which allow to place the sensors in the best position possible, the analysis of a large amount of data, automated systems, artificial intelligence systems, and also there's a need for us to understand what is that we have been reviewing, and that is saving a lot of money. So that's all on my side. Thank you very much.
Muchas gracias, Carlos. A continuación vamos.
Carlos, now we're going to listen to the third speaker for the session, who's Mr. Bartolomé Marquez. He's Deputy General Director of INTA. He's an aeronautical engineer, and he specialized in missiles and propelling engines. In 1984, he entered the INTA as a trial engineer, taking part in the C-103, CN-235, and Tamir planes. The Department of Air Navigation was created, and it was responsible for the Spanish side of the certification of the Eurofighter. He is responsible for the certification of planes such as C-235 Super Puma, CL-205P, Falcon 20, or C-295. He's also the head of the Design Standard Working Group, and now you're no longer the head of that. Okay, he's the head of certification of Airbus 400 and 400M. And in 2005, he was appointed the General's Deputy Director of Aeronautic Systems at the INTA.
Buenos días a todos, si se me permite.
To everyone, and first I'd like to thank Mapfre. I want to very warmly thank them. It's a company who has worked with us hand in hand from the very beginning. And I want to thank them for having me in their minds. In my presentation stems from a word with my two counterparts did not dare to propose, which is that of certification. And I like starting through certification because it's got a very clear link with insurance companies, because of course certifying in familiar terms means that an airplane or a plane is safe for flying, and of course an insurance company wants planes to be safe for flying. So the first news from certification I had was from Lloyd's, which established that there was the need for a series of requirements, so risks being run by planes could be assumed to a certain extent. It's just that the INTA, they tell me that we are the big unknown elephant, even if we are a research institution like the Spanish Higher Research Council. In terms of size and activity, we are the second institution in Spain, and we are there to serve society. But in the certification side, we are the technical certification department for the Ministry of Defense, so it gives us a kind of special aura. But I can tell you that we are in the most secluded corners. For example, we are in Mars, the environmental system telling us the temperature and the wind in Mars every day. It is a system which was developed and designed and placed in Mars by the INTA through their astrobiology center. So we're becoming 75 years old. That's most important. We were born in 1942. We're not an institution which was born yesterday. It was a very important decision, and for those of you who know history, the two leaves of the creation of the INTA showed an incredible ability for forecasting. We're located all throughout Spain, people think we are just an office in Madrid, but you can be surprised. We're present everywhere in Spain. We've grown a little bit more. The Cora law of the exposition affected us, so the ministry decided that all technological centers linked to the defense ministry were integrated into the INTA. So the INTA covers the Crane Park. There's the and equipment. The biggest machine for stress measurement in concrete in the country is run by the INTA, by the INTA. So we are active mostly in the military world, but also in the civil world. And now that I'm going to enter into my field of specialty, you should know that we have a series of places, centers. We have quite a large hangar which is being used by a Swiss aeronautics company because they're improving the planes. Granada is quite a special place because of the size of the airport and the low density of flights. Of course, also in Seville, in Cuadros, and in Arenosillo. So I also always like to say that the term drone was born there because for us, I never use it because for us a drone is a flying target, and the INTA has been using it for more than 30 years, and it's used for training. Of course, it's used for the same things we're using. Missiles should put down those targets, so it's a form of training. That's what we have been using the term drone for. So for us, drone is a term like referring to something which is silly. For us, it was an element which was there just to be hunted down. So the term we use is UAS, unmanned aerial systems. I always like to use a sentence here. My colleagues have used the sentence, and I always use the same. Everything is done and everything is yet to be done. Well, it means that the technologies are there, but it is fully developed for unmanned vehicles to be manufactured. But if you let me indulge into this subject, then many of you, I'm sure, you have gone into a lift of the new lifts, and you may see that all people lived a transition from a lift where there was someone, a gentleman with a cup saying, "Good morning, Mrs. Smith," and would press, and there was a lever which was a brake, and in some years they found that there was just a lift with a series of buttons, and the question was, will it bring me up to the 4th level, and if it fails, who's going to pull the lever? So there was a need for an adaptation process to take place, and we're also undergoing an adaptation process. For example, in a 3rd level category airport, where's the human hand there? But it's just for me to generate a bit of a discussion I want to generate.
It's important to know that a drone is not an aircraft. It is a system. It's a very curious system that is affecting many elements nobody is thinking about, because everybody is thinking about machines or things that are operating in areas that are very well identified and localized. But this machine has radio-electrical issues. They have their own frequencies that are authorized. Only some people have specialized radio frequencies because they go to many different places in Spain, and then we must make sure that those frequencies are going to be protected, and our bands are now within the same bands of the mobile phones. And in the telecommunication authorities want us to use a different system. But of course, in order to do such a change, we need to invest a lot. the general direction of communications says that a drone is an electronic system that is transmitting information more than other flighting systems, and this is something we all need to take into account. So that's the discussion there, and I come from the certification world, and certification is key. We need to guarantee the safety for flight. When it's not possible, when the methodology is difficult for new technologies, that's a big problem there. We all know that it should be certified to guarantee that the aircraft is safe for flight. But what's the certification I should apply to this thing that is coming from a toy, that was developed from a toy? But if I apply the normal ordinary regulation, they wouldn't pass. They wouldn't get certified. So now we hear many people saying we need to go towards simulation and try find alternative ways of certification. And there's, for example, 300 different models. And how many tests do you have to do? And these are phantoms only. How many thousands of phantoms are flying? And I mean, if the owners were really strict and once registered, they would inform of the problems that exist, then of course we could define specific safety procedures, but we don't get that information, and therefore the effect is the opposite. There are too many unknown things, unknown elements, and this is therefore something we should all reflect about. It's important to, show the administration that we can trust you. In order to change the administration, we really need to show the administration that we can trust, that they can trust us. And this is not just one direction. If there are no guarantees, then there will be limitations. The FDA site, that's where we see it's forbidden to fly drones. There are no recommendations for improvement. The information is a ban, and this should be changed. So this is affecting everyone. Design, production, maintenance. This is something that is covering everything. So what happens if the visibility is not trusted, has not been verified? Then we limit the operation. And where? Well, operation will only be allowed in areas where no damages can be produced, maybe caused, because I cannot certify the drones, and that's why they have to fly there. And I'd like everyone to understand this. The limitations will disappear when we get more guarantees and when we can certify the systems. So the certification is necessary, and we're not really going against the development of progress, or that we want to hamper business investment and so on. No, and I heard people saying such things just a day and a half ago in Malaga. We need to understand the context. So we are in certification in 2008, but it was in the 90s when we started with UAS certification, and this means that we researching them in the 90s, so a lot of efforts have been deployed. 108 certifications applied to 37 different models. So also there was an important project, Rapaz. And the thing is, okay, there are many manufacturers and you want to use them, that's good. But then we were told, okay, you need to show us prove us that you can do it according to some regulations, and we discovered all sort of things. I can't tell you the details, but you could laugh a lot. My friend Eduardo knows that. You know, people say what they do, and then we see what the actual devices truly do. And that's really interesting to allow us. That was a project that allowed us to know the development of drones in this country. I think you agree with me, don't you? And that was a very important point. So we're talking about technologies, and now we're talking about technologies that have shown that we have focused a lot in research. And we discovered an essential thing. There was a terrible thing I do not dare mention that caused many victims, this volcano, and there were different areas and no planes were flying, and there were red areas that disappeared in just 10 days. And nobody wondered why, but it was great, because that meant that we could fly a lot more. And it disappeared because loads of research planes that was really costly, and 8 engines to the British, we were flying in the black areas and in the red areas. And we discovered that in the red areas, the data from the prediction system, and we checked that the values did not correspond at all with the prediction values, and this means that we could, actually fly there. And this means that the UFAR group, the group of the Association of Research Planes, well, they showed that we should be able to have some elements available, and we're carrying out many efforts. We're talking about a 1.5 ton device that should be able to go into the black area to determine the real situation for aviation, and that's one of the goals. So that's the thing, to be able to improve safety issues in aviation. There are really funny situations, drones that are hunted. But this is a development coming from tuna fishers. Tuna fishers had to hire a helicopter to localize the tuna fish. But if you use this type of drone, well, that's a lot cheaper, but how do you make it land? Well, you need to hunt it like that. Hunting a drone that's flying. So that's the regulation, more or less. Here you have it from the FINAS group, from the NATO. And they decided to allow military drones to start flying in the civil area, just like the military planes do. They fulfill the same requirements as civil planes. In this military field, there's a lot of development of weapons, because the main goal is operation, not safety. And there, collateral effects are always positive. You're flying over your enemy, so if there's a failure and an accident, well, some more enemies will die. But would any of you be willing to have a drone flying over your heads if you know failures are possible? And also we are asking the military technology to do border control, marine inspection, and lots of things. A certain development is necessary. So these are standards that have been already implemented. The oldest one is a European CS-23, And why did the NATO decide to use the European standard, even though the Americans have a greater weight? Because in Europe there are many countries and it was a harmonized standard. So this is the standard has been used, and adapting some elements from the communications standards and also eliminating the parts on the pilots. Okay.
En general, para los aviones grandes, la certificación.
For big planes, we usually have industrial certifications, but this has many advantages. These planes will be exportable. They have a guarantee of a product, and the plane can go into a market. A certified product is a product that can have a future. Of course, it is costly to certify, but in the end, this becomes a benefit for the certified products, and this is extremely important. This cost does have a real outcome, a real result. And here we have just a picture. Our industry is in the world, and one of the important things is that they've got loads of blue boxes, and this means there is an exact acknowledgement. So the certification that has been signed here by the Spanish authorities, when they go to those places with the blue box, this certification is automatically acknowledged by the receiving country. And this is really important. This means that they can go to abroad. And I like to show this because it really shows the degree of expansion of the Spanish industry and how we've been operating. And now we're really going into the extreme east. We need to seek a market, and we must do it with smart views. Something else I'd like to say is why RPAs have not been developed so much, or why not until recently, because there were no motivations. We need to show this is safe, this is secure. In the world, these are the only centers where unmanned vehicles can be developed. And this explains why our friends in Europe think that we have a great capacity of the development of this technology. This is really important, that we're talking about civil developments. The universities in the US have been on this for like 3 years. Spain has carried out an enormous economic effort for this. The Ministry for Economy is investing really a lot on this, and we need to highlight this. I want everybody to know this. These investments will be over 50 million euros, and we're in the middle of the crisis, and everybody should know this. And I'd like to finish mentioning the airfield in Rozas, in the province of Lugo. This has been recovered, and many flights take place of several developers, of our own vehicles too. A great airfield with a great infrastructure, and now they're receiving the latest generation infrastructure and technology, because we really need to accompany the development of technology with the appropriate state-of-the-art technology, and this implies costs that we're also covering. Here we have the scientific concerns in relation to atmospheric research. And as you see, there are many different elements there. And, well, Spain, the only real demonstration that has been carried out of UAS, of real flight, was done with all the organizations, the civil aviation, the military aviation, which is the plane of over 60 kilograms with 6 hours of autonomy, and also this other plane that is a research plane. Because they were this was carried out in Salamanca with great results, and we chose those two models because they were more compatible. This is very important here. This area in Fedea, we don't have a runway yet. In a couple of years' time, we will have one runway of about 2 kilometers height, and we have a great advantage, a size of 150 kilometers by 50 kilometers, and it's the biggest one you can find. Here the weather is great, and the greatest danger can be a lynx biting you, but in the north you can be eaten by a bear, and that's a real danger. And there 10 million euros have been invested in equipment, and it's the latest technology. It's the most modern center that exists in Europe. So I hope I created a positive curiosity for you, and that you're not afraid of the word certification anymore. Thank you very much.
Muchas gracias, Bartolomé. Bueno, ahora vamos con retraso. Simplemente si tienen
very much. We are already quite late. With regards to the agenda, do you have any urgent questions?
Buenos días, Gabriel Santos, de Metro de Madrid, de la Junta Directiva PICI.
Santos from the Underground in Madrid. I have a question for you. Are there any experiences for the use of drones indoors? And also, are there any certifications for that? The only case I've heard of, I know, is the use in greenhouses. The problem is that these devices use a GPS, and of course if you're going indoors it's not possible, but you could use a different type of emitters with a signal to allow you to localize the device. Well, I'm asking because I was thinking about the different situations that happen, for example, in long tunnels, also guiding in emergencies, also for infrared cameras in case of smoke, and also electrical facilities and cables. You know, we can work with smaller devices and miniaturization. This, of course, has many advantages. And there's a great number of opportunities and possibilities, and that's why I was asking you about this. If you allow me, I can tell you a bit more about this. Even indoor, we have carried out several inspections in biofuel tanks with no GPS signal, and it's really a critical situation. You're inside a metallic tank, a steel tank usually, so there is a wave reflectivity, there is continuous, no GPS, and it really is critical. So the only option there is by hand and pilot. But we have developed, and well, there are less technologies, but they are advancing, and now there are laser team equipment that carry out an automatic inspection of the space, and with an autopilot with LiDAR, we're talking about 600 grams with a logic of mathematical computation. And this means that with this type of systems, you can save in weight, and it's very safe. We had a development of an R&D product for high-speed trains, and we used LiDAR and thermography to be able to do inspection at night, for looking for obstacles, also for the catenary and the railways. But in a tunnel you need to have a specific application, and we have not really checked yet the distance, the reach. So currently it's LiDAR that we can use, but there's been a great development of the mathematical computation, and well, this is being used for inspections. And for pipes, in fact, there's a great system that has been developed in Switzerland with a size of 36 centimeters, and there you can inspect those pipes. But there's still an issue, because if the drone gets blocked in the pipe, well, what are you going to do to solve that? Perhaps you would need to eliminate that pipe. Well, we're working on this, and there are new researchers in this field. Okay? If there are no other questions, we're going to close this session, and we will drink well-deserved coffee. Thank you.